Yeah, hello everyone, and now in this video we'll discuss about the some of the problems that were asked in your daily quiz for third week of June for engineering mathematics subject. Okay, so there were around like 4, 5, or maybe 5, 6 problems here from different topics. Okay, so we'll discuss them one by one. Okay, so let's get started. So this is the first problem where they are talking about you are supposed to find the area of the region enclosed by graphs of the equation y equal to x, y equal to 2x, and x equal to 4. Okay, so y equal to x is a straight line with slope of 45 degree, or you can call it as slope of 1 also. And y equal to 2x is a line with double the slope than the y equal to x. So basically, you can easily draw one simple schematic. Okay, so this is your xy plane, Cartesian 2D Cartesian plane, and y equal to x will look something like this. Okay, this will be a y equal to x line, and y equal to 2x will have higher slope. Okay, so it will look something like this. So this will be y equal to 2x. Okay, and then you'll have I think x equal to 4, right? Yeah, x equal to 4 is somewhere around here. So let's say this is here x equal to 4 line. Okay, so if you consider the area that is bounded by all these three lines is this area, which is shown by a green shade. Okay, so you are supposed to find the area of this triangle basically. Okay, so now if you do simple this thing, the coordinates, try to find the coordinates of vertices of this triangle. So this image is not to the scale, so in reality it may look different also when you draw it up to the scale, but that's not the point. Okay, here we are supposed to solve the question, and since this vertex lies on y equal to x and x equal to 4, so here it will be 4 4 because y and x both have to be same. Similarly, there is a one vertex at origin, and here x is 4 and y will be 8. Okay, so these are three vertices of your triangle. Okay, and now they are interested in finding the area of this shaded green shaded region. Okay, so there are multiple ways to do this. One is from here only you can see, because we know that area of a triangle is nothing but half into base into height. Okay, this is standard formula. So if you go back to this figure, what you can do very quickly is consider this as the height. Okay, and this length as the base. Okay, so height is nothing but 4 and base is also 4. Okay, so therefore it will be half 4 into 4, so that is 16 by 2, that is 8. Okay, so the area is 8 unit or square unit, you can say. Okay, because they have not mentioned which unit they are talking, so I think that is not asked also. So it's a data entry type of question, so you are just supposed to put the answer, and 8 is the correct answer. So this is one way to do about this. Okay, but there are other ways to do the calculation also. For example, if you know the vertices, you can use the formula from your matrices also, and that is half into determinant of a 3 by 3 matrix. Okay, so x1 and y1 is the first vertex, x2 y2 is the second vertex, and similarly x3 y3 is the third vertex of the triangle. Okay, and then here if you do that, x1 y1 is 0, that's why it is the easier way to do this, and x2 y2, let's say 4 4, that is one of the vertex, and the other one is x is 4 and y is 8. Okay, so you should know how to calculate the determinant of a 3 by 3 matrix. So there are 2 zeros in the first row, so only the third element 1 will be useful to us. So that will be just half into 1 into 32 minus 16. Okay, so that is also 16 by 2, that is also 8. Okay, so From this method also you are getting the same answer. This determinant based method is useful when you know the vertices of the triangles. Okay, otherwise it is not that useful. I mean, first you need to find the vertices, and in some cases those coordinates may be very difficult to find also. Okay, so one formula is this half base into ice, applicable everywhere. Another is this one, and in some cases when you know, for example, if you are considering some triangle like this, so if you know the length of the sides, okay, so there is something called as Heron's formula. Okay, so this is not pertinent to this question only, but since we are discussing, I'll just give you the formula also. And here you first calculate the semi-perimeter, that will be sum of all the sides divided by 2, and then the area of this triangle will be nothing but square root s into s minus a, s minus b, s minus. Okay, so this is called as Heron's formula. It is not useful in the given question because you don't know the sides, length of the sides of the triangle, but in some problems, if they are asking you to find the area and the length of the sides is easier to calculate, you can use that also. You can solve this given problem also using this Heron's formula, but first you need to find the length of the sides. Okay, so you can take that as a homework also. And in that, answer should be 8 only. Any which way you do, answer should be 8. Okay. So now let's move on to the next question. So now again, here also they are talking about area bounded by y equal to e power x and y equal to e power minus x, and between some x, constant x value. Okay. So here also first thing you should do is do a schematic, rough schematic, so that you get some idea about what basically they are asking. So y equal to x is a monotonically, y equal to e power x is a monotonically increasing function. And when you put, let's say this is your origin, so this is your origin. So when you put x equal to 0, y is turning out to be 1. So it is some function like this. Okay, so this will be your y equal to e power x. And if this is your origin, this point will be nothing but x is 0, y is 1. Okay, so this is about y equal to e power x. Then you can look at the other function, which is y equal to e power minus x. That is a monotonically decreasing function, and it also passes through the same point, y equal to 1. Okay, so it will be something like this. Okay, so e power minus x. And then they are telling you that you consider some x value, which is ln of 3, and now you are supposed to find the area shown by this red shade. Okay, so this is your objective here. Okay, now again, this is not a general area where like a triangle or a square or a rectangle, so you don't have a direct formula to find this area of this shaded region. So what you can do here is basically this is the standard practice that we do in these kind of problems, is nothing but you take a vertical strip. Okay, you can take horizontal strip also, but you'll realize in this problem it is easier to do it this way because the x limits are easier to do. Okay, so let's take one strip of ds thickness. So the y values here is e power x, and at the bottom, so this is the thickness, and the function at the bottom is nothing but y equal to e power minus x, right? So area will be nothing but this difference of these y values into dx, and then you integrate with respect to x, right? You can do the same exercise by taking horizontal strips also and do the integration with respect to y, but that is the difficult way. This one is the easier way because your x limits are, x is going from 0 to ln of 3. So therefore, you take vertical strips, stack them together. That is the easier way. Okay. So therefore, required area will be integrating x going from 0 to ln of 3 e power x minus e power minus x dx. Okay. Again, you don't take e power x only because that will give you the total area between that y equal to x and the x-axis. We don't want that. We want the area between y equal to e power x and y equal to e power minus x. Okay, so that is why this expression is there. And then you do the integration. Okay, so e power x integration is e power x only, and e power minus x integration will be minus e power x, so that becomes minus minus plus. Okay, it goes from ln x goes from 0 to 3. Okay, and then you are supposed to put the limits, and if you do that, that upper limit will give you e power ln of 3, that is just 3, plus e power minus ln of 3, that will be 1 by 3, minus e power 0 is 1, 1 sorry, and e power minus x also, if you put x equal to 0, that is 1. So this is nothing but 3 minus 2 1 plus 1 by 3, that is 4 by 3. Okay, so this is your answer, so option B. And yeah, that is also the same given answer key is also the same answer. Okay, so this is again a problem based on the interpretation of the graphs of different functions. Okay, okay, so you just need to determine whether you do the integration with respect to x or y, whichever is the easier option, do that way. Okay, you will get the same answer if you do integration with respect to y strips also, I mean horizontal strips, and if you stack them in y direction. Okay, but that is a difficult integration to do. Okay, and then the next question is area enclosed within the curve mod x plus mod y equal to 1. Okay, so the main thing in this is nothing but to plot this curve. That is the important part. If you are able to do that, you should be able to solve the question pretty quickly. Okay, so now let's do that. Okay, so what we are trying to do, because this mod, no, this is very frequently asked kind of function in your GATE exam. So let's consider this as your origin. Okay, and let's say this is your first quadrant. In first quadrant, x and y both are positive, so this function will be nothing but x plus y equal to 1. Okay, because when x and y both are positive, mod x means just x, mod y just means y. So that is nothing but line of a, I mean this you can write y equal to minus x plus 1. The intercept is positive 1 and the slope is minus 1, so it will be something like this. Okay, this will be 1 comma 0 and this point will be 0 comma 1. So this is the story of first quadrant. In second quadrant, what happens? X is negative but y is still positive. In that case, mod x will be minus x and mod y will be just y equal to 1. So therefore your line is nothing but y equal to x plus 1. Okay, so that means it is a line with positive slope and the intercept of 1. So it will be something like this, and here x will be minus 1, y will be 0. Okay, and similarly you are supposed to do this exercise in all the quadrants. Okay, so this will be x negative, y negative, and in that case it will be minus x minus y equal to 1. Okay, so that will be y equal to minus x plus 1, minus x minus 1. Okay, so this will be something like this. Okay, and in the end it will be 0 comma minus 1. Okay, and here this is the fourth quadrant where x is positive, y is negative, so here it will be x minus y equal to 1. Okay, and now if you see, this is nothing but the square, no, all sides are equal. Okay, and side length is square root of 2. Okay, you can do Pythagoras calculation or whatever you can do, because this is a right angle triangle. Side length is 2, so this mod x plus mod y equal to 1 is a square with side of square root of 2. Okay, so therefore area will be nothing but area of a square is side square. Okay, so therefore it is root 2 square, that is just 2. Okay, yeah, and the answer is also 2. Okay, yeah, so this is one of the questions where if you knew the mod x and mod y notations, you should be able to solve this. Okay, just a second. Okay. So now this is the fourth question where they're asking you to do a Lorentz series expansion or Lorentz series for this function f of z equal to 1 by z cube into 1 minus z about z equal to 0. Okay. So in this case, this thing. Okay, so let's look at the options first, because you can just, I mean, there is a usual way to do this, but in this question it's a slightly different question, because the options are not in a conventional sense given. So if you look at the options, this term appears in all the options, which is summation of z power n going from 1 to infinity. Okay, it is all in 4 options. The only difference is the remaining terms. So here there is this 2 extra, here this 2 is there, here also 1 2 is there. Okay, and this 2 is also there. Okay, so these are the minor differences, but this term remains same in all the options. So that should be the hint to solve this question. Okay, so here what you can do is, because we know that if f of z is 1 by z cube into 1 minus z, you can write this as 1 by z cube as it is, and then this will be 1 minus z power minus 1. Okay, and use the binomial expansion formula. Okay, so what is the binomial expansion formula? This also we have done in the class, right? So this will be 1 plus x square plus x cube and so on and so forth. Okay, and one caveat here is mod of x should be less than 1, but more often than not they don't mention this condition. So we just implicitly assume that here also mod of z is less than 1. Okay, but strictly speaking that should also be mentioned in the question. Otherwise, if mod of z is greater than 1, this is not the correct expansion. 1 plus x square plus x cube, that is not the correct. If mod of x is greater than 1, then we do another kind of series expansion. Okay, but that is usually not considered, so let's not go there. So if you do that, what do you have here? 1 by z cube into 1 plus z square and so on and so forth. Okay, so there is no space here, so let's go to the next slide and then we'll expand this. Okay, so basically you are supposed to multiply by 1 by z cube, right? So this first term will be 1 by z cube, second will be 1 by z square, third will be 1 by z, fourth will be just 1, and then z square, z cube, and so on and so forth. Okay, and that is what you are supposed to catch. Okay, so plus 1 plus summation of z power n going from 1 to infinity. Okay, so therefore the correct answer should be with all the coefficients as 1. Okay, so that will be nothing but option number C. Okay, yeah, and that is also correct answer. Okay, so in this question, this was a question but not the conventional that you do, conventional Lorentz series expansions. Some problems we have taken in the regular classes also, but here you need to stop and look at the options. Okay, and then maybe get a hint and then solve the problem. Okay, so this was the critical step, to use the binomial expansion for 1 minus x power minus 1 or 1 minus z power minus 1. Okay, so if you do that, you should get this answer. Okay. So let's go to the next question. Yeah, so this is the question where they're talking about the singularity for this f of z e power z minus 1 by z. Okay, and at z equal to 0. So most of the students, what they will do, usually they just look at the denominator and they will say that this is the pole of order 1 at 0, right? Sometimes you can also call it a simple pole, but this is incorrect. Okay, so many of the students will tick this option, but that is not correct. Why? Because this is true, like it is a simple pole at z equal to 0 only if the numerator function is not 0. Okay, so this z equal to 0 is a simple pole only if this numerator, which is e power z minus 1, is not equal to 0 at z equal to 0. So if you put z equal to 0, you'll see that this denominator is going to 0, right? So this is actually becoming 0. So in such cases, okay, so if this numerator f of z is equal to 0 at z equal to 0, one must do Laurent series expansion. One must perform. Okay, and this is the very common type of a tricky question. Perform Laurent series expansion for f of z to determine the nature of pole at z equal to 0. Okay, so let's do that. Okay, no need to do anything new here because e power z is a standard function, that is nothing but 1 plus z square by 2 factorial plus z cube by 3 factorial, so on and so forth, minus 1 divided by z. Okay, so this 1 gets cancelled, and if you divide the whole thing by z, then you can write first term will become 1, okay, plus z by 2 factorial plus z square by 3 factorial, so on and so forth, right? So this is what your this thing becomes. You say your f of z series expansion, Laurent series expansion. Okay, and now if you see at z equal to 0, f of z is just 1. Okay, so therefore no pole or singularity for f of z at z equal to 0. Okay, and therefore it is a removable singularity. Okay, so this is the classic trap in this kind of questions, and this has been asked multiple times in your GATE exam also. Okay, so many of the students do not consider the value of numerator when they check the pole, and that's where they make a mistake. Okay, so here the correct answer is option A, not option C. Okay, and that is also as per your answer key. Okay, so just make sure whenever you are checking the pole or anything, just when f of z is a numerator and denominator kind of function, make sure that numerator is non-zero at the pole, only denominator goes to 0. That's when the whole function goes to plus minus infinity. Okay, but if both are going to 0, then you cannot say anything. You have to further do the Laurent series expansion for the f of z. Okay, and now let's solve the next question. So this is also a classic question where you are supposed to find the residue for this given f of z, and the closed contour that you are considering is a circle given by equation of z plus 2 equal to 1. Okay, so this z plus 2 is nothing but circle centered at z equal to minus 2 and radius is equal to 1. Okay, so this is the information that is given in the question. So let's go to the next slide. So if you look at your f of z as well, z plus 1 is okay in the numerator, but if you look at the denominator, you can write it as z plus 2 whole square. Okay, so it is a plus b whole square kind of denominator, and then the contour that you are looking into, if this is your origin on your complex plane, z equal to minus 2 and radius 1. Okay, so let's consider this as minus 2, this as minus 1. So it will be a circle something like this. Okay, my drawing is not up to the scale, but you get the idea, right? So this will be minus 1 and this will be minus 3 because radius is 1. Okay, and this will be 1 or I, and this will be minus I. Okay, so this is your C, closed contour C, and they have not mentioned any direction, so we can assume counterclockwise because that is a positive direction, conventionally assumed like that. Okay, so if you do that, now we are supposed to find the residue. Okay, but if you look at this, this f of z has pole at z equal to minus 2. Okay, and that minus 2 point is inside the closed contour C, so you are supposed to consider the residue. Okay, and one more thing is this pole at z minus 2 with order equal to 2. Okay, so it is a double pole at z equal to -2, and that is inside your closed contour C also, so residue will be considered. Okay, if the pole is outside your closed contour C, then in that case we consider like there is no residue because of that pole, because it is outside of your region of interest. Okay, so in that case, when you have repeated poles, the general formula is nothing but, let's say, if f of z has pole of order m at z equal to z naught, then if you want to find the residue at z equal to z naught, it is nothing but limit z tending to z naught. Then you're supposed to differentiate it one order less with respect to z. Okay, so this is m minus 1th derivative of z minus z naught whole power m into f of z. And yeah, one more multiplier is there, which is 1 by m minus 1 factorial. Okay, m minus 1 factorial is also there. So that is outside this differentiation. Okay, so maybe I'll rewrite this because otherwise it's confusing. I forgot that multiplier. Okay, so here 1 minus 1 by m minus 1 factorial will be there. Then limit, limit is already there, not limit, that derivative. Yeah, dm minus 1 dzm minus 1 and then z minus z naught power m into f of z. Yeah, so this is the complete formula. So here we have in this problem z naught is -2 and m is 2 because it's a double pole at -2. Okay, so therefore residue at z equal to -2 is nothing but limit z tending to -2 1 by 2 minus 1 factorial, so that is just 1 factorial, and you are supposed to take the first derivative here because the pole is of the second order, and then z minus it is minus, no, so it will be plus, minus minus will become plus, square into f of z. What is f of z? Z plus 1 by z plus 2 whole square. Okay, so this term gets cancelled, and now if you look at this, residue at z equal to -2 is nothing but limit z tending to -2 1 by 2 minus 1 factorial is just 1, and then derivative of z plus 1 with respect to z is just 1. Okay, so therefore the residue is just 1. Okay, like we need not to put any limits also here, and therefore the answer should be 1. Okay, and that is option D. Okay, and that is also as per your answer. Okay, so this is the classic case where you have a repeated pole or higher order pole and you are supposed to find the residue. First, make sure that it is inside your contour C, then only non-zero value will be considered, otherwise it's 0. And then you are supposed to use the formula which we have discussed multiple times in our regular classes. Okay, and I think that is the end of this quiz questions. Okay, so with that we'll stop here and we'll meet next time. Okay.